This session is based on a particular topic for composite analysis. So consider this session to be a kind of series kind of sessions, like the webinars that we are going to plan from here to like whatever the forward further sessions will be there. So those will be in a particular series. So as of now, this particular session is dedicatedly like made for the persons, made for the users. Those are totally new for the composite analysis using Ansys software. So first of all, this session will be a kind of introductory session for them, a kind of introductory webinar. So how they can make use of the particular Ansys composite pre-post simulation software and how they can integrate the Ansys ACP module with the Ansys mechanical so that they can get familiar with the particular software, and we'll have some demonstration kind of stuff while performing the simulations. So I won't go much into the theory over here. So we'll directly begin with the demonstration itself, because most of you might be known with the composite. So as we all do know, what is a composite material? How is it made? So usually what we used to do whenever we want to do the particular simulations on composite model is we used to create the plies with respect to the thickness of the particular composite ply, and then we used to define the particular model with the material that we are considering for integration of the composites. So over here, the composition, the particular combination of the materials that we will be going use for creating a composite will be totally virtual itself, like through the Ansys ACP module. And how the particular Ansys mechanical can be integrated with the Ansys ACP module. Like previously, we were having the Ansys ACP module where we can do the pre-processing part as well and the post-processing part as well. But as of now, with the latest version, we don't have the Ansys post-processing part. But even the users who are more familiar with the particular previous versions itself, like before 2025 versions, so like 2024 or 2023, they can still utilize the Ansys composite post module over here as well. So I'll go with both the things, like how we can do the post processing part in the Ansys ACP module as well and Ansys mechanical as well. So this particular session will be totally a demonstrative session where we'll have a particular model that we will be going to use for the particular simulation, where we'll select the type of material that we want to use to create the composite material. Then we'll define the particular thicknesses, we'll generate the mesh, we'll define the orientations, we'll define the particular sets, we'll define the layups, stack ups, all those things, those are required for designing a composite material over here. And then how we can particularly using that composite material itself, how we can on a go through use that particular material for for defining the same kind of material to the geometry, how we can make use of the varying thickness in the geometry to be designed and defined with respect to the composites. All those things we are going to discuss in this particular session. So first of all, we'll go with the agenda that we are going to follow for this particular session over here will be. So we'll have an introduction to ACP, like what is the ACP module, how it does works, what are the things that we need to follow whenever we are performing a particular ACP simulation, making you guys familiar with the ACP tool, what kind of things are present, what kind of tools are present in the ACP module and all those things. Then later on, how we can do the composite modeling using ANSYS ACP, like ply definitions, orientations, and stack up sequences. And then later on, once all these things are done, how we can do the ply modeling or either the solid modeling using the materials that we have designed. Then later on, we'll go for the next step, that is integration with ANSYS mechanical, where we'll do the particular structural simulation on the composite parts. See, like it is not compulsory or mandatory, like whenever we are considering a particular body for simulation, that overall body should be made up of a composite material itself. So that particular composition of what kind of material should be available in your particular geometry and what kind of material should be defined for your geometry, they can vary with respect to the particular either span wise, like if you are trying to design any kind of body, so that body can be made up of different kind of materials. Even you can combine those with the particular conventional material, like either steels, alloys, metals, and all other things, or either you can design those using the composite as well. And even they can be a combination of both of them. So how particularly ACP will help you with designing such kind of models? Uh, we'll discuss about those things while demonstration, at the time of demonstration itself. So that particular demonstration will be on a kite board. So I'll showcase you how, what kind of model that it is, and how does the model does look like, and how we are going to apply the varying thickness for the composite material using the kind of model that we have. So all those things we'll discuss over here. Then building and analyzing simple composite model. We'll go with a step-by-step procedure from how to select the material, how to select the geometry, and then how to particularly define fibers, their orientation, their stack ups, their plies, and all other things we'll discuss in more detail, and we'll go step by step over there. And at the end, we'll see how the post processing part can be done. So we'll see the post processing part in Ansys mechanical as well. When we'll perform the structural analysis on the composite that we have made, we'll even do the post processing part over there. And even we'll do the post processing part using Ansys ACP. So those who guys are like familiar with Ansys ACP post simulations, so that post processing part, so the particular tool, how they can utilize it for doing the post processing, and how the particular Ansys mechanical software can be used for doing the post processing part of the composite simulation. We'll focus on both the things. See, now from 2025 R1 version, so they have removed the Ansys post processing module from the tool or modules those were available in the Ansys workbench. So basically from now onwards, we need to do the post-processing part using Ansys Mechanical. So those who are new with the particular software, they can only focus on the Ansys Mechanical post-processing part, so that they don't have to learn the another software or another tool for the post-processing. So everything that can be done in Ansys ACP module for the post-processing, that can also be done in Ansys Mechanical. So we'll go through them as well. Uh, then how to find out the stresses ply wise, or either stack up wise, or whatever kind of body that you want to find out the result with respect to it, or either with respect to the composites and all other things, you can do those things as well. The failures in the composite models that can be also found out using both the tools will go sequentially with respect to the demonstration that we are going to perform. And at the end we will have a question and answer session. So we'll wrap up with it. So first of all, this particular demonstration is on a kite board. So most of you guys might have heard about a kite board model. So this particular kite board will use for the simulation over here. I have a geometry with me, so which is the same kind of representation of the kite board. At the end of the session, you guys can mention it in the chat box if you guys need the particular model, so that you can do practice on it. So with respect to the recorded sessions, we'll also share the particular certificates for the participation, and I'll even share the particular models with you. So even if anyone wants to connect with me, I have already mentioned my mail ID in the first slide itself. So you guys can have it from there, and even I'll share it at the end of the session. So in this particular workshop, we have a particular kiteboard model. We'll use that particular kiteboard model, and we'll go through the overall process from how the modeling is done of the kiteboard, then from modeling till to the particular composite material selection, then the overall composite simulation, and then the structural simulation and the post-processing part. So we'll go through all this particular process in a step-by-step manner, and we'll also learn. So as you can see, this particular model which is mentioned over here, there is a particular variable thickness in the overall like lengthwise direction. If you would check it over here, there are particular variable like variations in the thickness of the model. So how we can manage such kind of variation when we are trying to design the particular composite material? Because composite can be either designed with respect to the particular thickness that we are defining, but how we can use this variable like variable thicknesses which is present in the model, that can be directly defined to the composite when we are trying to design it. So we'll look into that perspective also. So as you can see in ACP, the approach is model as you build it. So basically that's why we are using the particular variable thickness through the geometry which is already been available with us. So each ply of the laminate is directly applied on the shell mesh. So basically whatever the model that we will be going to use for the initial, that particular model itself is generated with respect to some kind of mesh over there. And on that particular mesh, see, basically whenever you are using your model for the particular composite designing, so either it will be a surface model or either it will be a particular solid model directly. So solid model will be the advanced part that we will cover in the upcoming sessions for this particular series webinar. As of now, we are just focusing on how we can do the particular composite simulation on the particular surface models. So over here, like whenever we are using the initial model, so usually on a surface model, shell mesh is getting generated. So we can use that particular shell mesh as a particular mold kind of thing, where we can apply the laminates that we were going to create in the particular composite, that is ACP, and we will apply that particular ply or laminate that we have created through the ply on the particular shell mesh that we have created over here using the design. So all those things we are going to see. And this particular application, as you can see, is mentioned with respect to the 45-degree orientation of the oven glass fiber mat over a wooden core. So basically the properties for this particular materials are also shared in this particular slide itself. So we'll look into those things as well. And even there is a particular foam core laying between the oven mats before lamination. So we will see into those things as well. So how this particular like core material is also used and how the particular glass fiber material is also used for the simulation. So you can see a virtual geometry can be used. So as this particular thing, whatever it is mentioned over here was with respect to the particular surface geometry that we do have. So it was creating a shell mesh. But later on, once we have a particular laminate that has been molded on the particular shell mesh, later on that has been particularly laminated on the mold, that is the surface mesh. Later on, to provide the thickness with respect to the surface, that is in a varying manner for this particular kite board, how we can define it, because defining it through a particular manual process is a little bit complicated thing. So how we can use the particular virtual geometry, that means the actual 3D model of the kite board, and define the particular complex thicknesses. So how it can be done, how we can particularly replace the thickness that we did provided to the initial dummy model, and how the particular actual thickness of the model can be defined directly to the particular composite material using Ansys ACP pre and Ansys mechanical. We'll see those things as well in this particular simulation. Then the particular dimensions, the stack up orientation, the stack up angles, the ply angles and all other things, the fiber orientation and all other things are mentioned over here. So as you can see, the kind of materials that we are going to use for the simulation will be a carbon fiber material, which is in a stack up of a particular 45-degree minus 45-degree orientation, 0 degree and 45 degree. So that will be a particular stack up of different, like the same or either different kind of particular fibers that we are going to use for the simulation. Then there will be a foam core that will be available, which will have a thickness of 17.5. So this will be the maximum thickness. So we will decide what kind of thickness we should provide for the overall model. And then there will be another stack up model, which will be stack up laminate which will be available, so that the overall covering of the model will be done over here. The layer from top to bottom has been mentioned over here, and we'll go through it. The material definition, like what kind of materials we'll be using for the simulation is mentioned over here. So the core material properties are mentioned, and whatever the woven material will be there, we'll use the same material which is present in the engineering data. We won't be like defining different kind of materials manually over here. We'll only define the core material manually. The properties for the core material are defined over here. We'll use the same kind of material for this uh, core material to be designed. So just a second. We'll now begin directly with the particular simulation itself. So now you can see whatever the actual model which was present with us, that is the core thickness model. So to define the thickness with respect to the model, how we can use the actual model which we have designed in Ansys ACP so that we can define the varying thickness. We'll look into that process as I did mention. So we'll directly begin with the Ansys workbench over here. So as this is the graphic user interface of the workbench screen over here. First of all, you can find out the ACP modules over here in the ACP component system, that is ACP post and ACP pre. As of now, I'm using the Ansys 2024 R2 version over here so that I can even go with the mechanical post processing and even be with the Ansys ACP post processing part. Because from 25 R1 itself, there is no ACP post processing model which is present over here. So I need to utilize both the things so that I can just showcase you guys. But from later on sessions, we won't be using the Ansys ACP post. We'll be directly using the Ansys mechanical itself for the post processing. So over here, first of all, to import the geometry, that is the surface model on which we are going to apply the plies or the laminates that we are going to create over here. So I will import the CAD model for the kite board over here. So I'll just click on geometry over here, import, choose the kite board model which is available over here. So I have both the models, that is which the model which does defines the surface of the particular kite board and even the particular variable thickness with respect to the core of the kite board model. So I'll share this both the models with you. So first of all, I'll be using the surface model over here. I'll just select the particular kite board and import it over here. I'll open it in ANSYS Space Claim. So this will be a step-by-step procedure. So if you guys have any kind of doubt within any step that I'm showcasing over here, you can just note it down and you can just ask the questions in the end of the session so that the overall flow won't get disturbed. So the model that I have imported in the geometry section is this particular kiteboard model. As you can see, this particular kiteboard model is divided into various number of surfaces. So you can keep the various number of surfaces as it is. If you want to define some particular different kind of composite material for each of the surfaces that has been discretized over here, or whether if you want to go with the same kind of laminate to be defined for the overall geometry which is available over here, then you can do one thing, that is you can go to the prepare tab. You need to repair this particular body that you have imported over here, which is in separate kind of surfaces form. You can just go to the repair tab and stitch over here. So it will automatically find out the area and it will convert the overall surfaces which are present into a single surface over here. So now I have the overall model, but with the number of divisions will remain the same. This is because there are extra edges which are present in the model. So I won't change the particular number of divisions which are made of the surfaces. Those are also having some different kind of uses in the particular simulation. We'll discuss about them in later on. So over here, I'll just rename this particular model as kiteboard. And I'll just minimize this particular window. So first of all, as we have to go with the ACP pre-processing part, where we'll import this particular geometry. First of all, while creating a composite material, the most important thing is we need to define the materials that we are going to use for the composition of the composites. So over here, I'll just choose the ACP pre, which is for the pre-processing part. I'll drop it on the geometry over here so that the geometry can be shared directly with the ACP pre. Now, first of all, I have to include the materials that I want to use for the simulation. So I'll just go to the engineering data over here. So those who might be already familiar with the workbench window or with the mechanical analysis, they might be known with how to define the engineering data, that is the materials, the geometry and all other things. Okay. Okay, I'll quickly import the model over here. that is the geometry model. I'll edit the model once again because it might be again in the various number of surfaces form. So I'll create it into a single surface so that even while performing the mesh, the model won't get divided into several number of like parts over there, so that even it will affect the mesh connectivity, and even there will be some kind of contact region into a single body itself. So those things will get affected if there are several number of parts in the geometry. So I'll just do the repairing process once again. Name it report, minimize it. Okay. Now I'll go to the engineering data over here. So first of all, like all of you might be familiar with the engineering data, like how to define the material, how to choose the material. So accordingly that I have mentioned in the PPT over here, I need to go with the materials. The properties have been mentioned for the core material. So we'll have just two materials with us. One will be a core material and one will be your particular carbon fiber material, which you can select whatever you want to from the composite material library, which is already been present in the engineering data. So over here, I'll just define the core material at the initial. So I'll just add a new material, naming it as core over here. So once it is selected, I'll define the properties, that is orthotropic elasticity property. So we'll just check. So the orthotropic elastic properties have been defined. The orthotropic homogeneous core is the ply type that we need to define for finding out any kind of failures. So basically, if you want to find out the failure in your particular composite model, you need to choose the ply type over here. And then you need to define the stress limits as well, which are with respect to the orthotropic stress limits itself for your particular composite material. So over here, I'll choose the particular ply type, that is drag this ply type and drop it on the core so that I can change the particular ply type from regular to an isotropic homogeneous core. Sorry, orthotropic homogeneous core. And then later on, I need to even define the stress limits over here so that I can decide the failure of the particular model. So the strength, yeah, orthotropic stress limits, I can drag them and drop it on the core over here. Now the properties that I need to define are in terms of megapascals over here. Those have been defined. That is 60 megapascals, 0.35 and 23 megapascals. So I'll just go with the same kind of thing over here. Change all the unit systems to megapascals. So like usually the changing of the unit system is done at the initial itself, but I didn't do it. So that's why the overall system was in terms of pascals itself. I need to even define the particular stress limit in compressive Z direction and the particular shear plane in XZ and YZ. So I'll just go with them. So first of all, the Young's modulus that was defined over there was 60 megapascals. 0.35 to be the Poisson's ratio in all the three planes. Then shear modulus was something around 23 megapascals. See, this is not a mandatory process. So I am just using the properties. Those are mentioned with me for the kiteboard body over here. If you don't want to define the properties over here in such a form, you can even use the core materials which are already present in the library. I'll just showcase you those materials as well. I'll just define the remaining properties over here. That is 1.1 megapascal. Then the shear strength and 0.08. Okay, so now once these are defined, all other are 0. Once these are defined over here, so you can use the core material. Now to import the other materials that you want to use for the particular composite material composition, I'll just click on the composite material library over here. You can see we have various different kind of materials. So I can use the epoxy carbon, which is a unidirectional material which is available over here. So I'll just see the material properties those have been defined for this particular material. I can use this elastic material for the simulation as the properties those have been defined for this material. Uh, like they can be elastic itself. So if it is required to define some other materials, then you can choose any one of them from this particular thing. So as we have to choose a particular woven material, so I can go for the particular epoxy carbon woven material over here. I can click on it and you can see the particular properties defined for it. So I can select this particular material, or either instead of it, I can go with the unidirectional material as well. Then instead of defining the particular core material, you could have used the particular foam materials as well. Even the honeycomb structure is also available, which has the orthotropic elasticity properties, the particular stress properties defined for them, and even the ply properties defined for them. So this particular honeycomb structure can be even used over there as a core material to increase the strength of that particular composite material. So if you want to use it, directly select this particular honeycomb structure over there. So instead of this woven material, I'll go with the unidirectional itself. So going to the project pack, I need to particularly define the particular thickness of the material and perform the meshing before I directly begin with the particular ACP setup over here. So I'll just click on the model in to open the Ansys mechanical and edit the particular geometric properties and even perform the meshing on the model. So I'll just select this. Okay, so as you can see, the body has been imported, the kite board. So I'll just click on this kite board model over here. See, whatever the kind of thickness that we need to define over here. As of now, the dimension of this particular body is held to be 3D over here, because I didn't change the geometry properties. That is, whenever I need to plug in some kind of geometry for the mechanical processing, I need to define the analysis type over here, which is mentioned to be 3D. So basically, if it is a 3D geometry, as we have to create the composite using all the three directions, I need to go with 3D itself. So if it is just a particular surface that you want to do the simulation with, you can choose it as a 2D kind of analysis, and your particular simulation for the composite processing as well will be in the 2D plane itself, that is in the XY plane. So over here, I have the particular dimensions to be defined. First of all, it is asking me for some kind of thickness of this board, because this is a particular 2D body that I have. I need to define some kind of thickness that can be considered for this geometric thickness of the body for the particular 3D simulation in the third direction or in the normal direction. But this particular thickness is just a particular like temporary kind of value that we are defining over here, or whatever the kind of material that has been selected over here, the structural steel material. It is just a particular like initial kind of material that we are defining, a temporary kind of values or the temporary kind of definitions that we are defining over here, whatever the actual values will be defined for this particular geometry with respect to the composite, those will be defined in the Ansys composite itself, that is ACP pre itself. So over here, to just generate the mesh so that the elements from this particular geometry can be transferred to the Ansys ACP, we are doing this particular process over here. So I'll define the thickness to be a particular default value to be 1 mm and assign the material to be the structural steel, because this will get automatically changed over there. So once this is done, I'll just go for the meshing. As I have to create some kind of mesh on this particular body, I'll just insert a body sizing over here, select this particular body and define a particular element size of 10 mm and just generate the mesh on the body. Usually whenever you have such kind of geometries with you, not just this particular kiteboard, whatever kind of bodies that you have with you, usually you need to create the name selections for the particular geometry so that the elements for each name selection can be like shared with the ACP in a different kind of like zones over there. So with respect to each zone which are present over here, as you can see these particular surfaces which are separately modeled over here. Basically, the elements which are present on this particular each surfaces separately can be shared with the ACP so that you can change the composite like materials over there. You can define various different kind of materials as well, or either you can define various different kind of thicknesses of the ply over there. So this can be done as an alternative processes if you want to change the particular composition of the overall body composite material composition over there. But as of now, we will go with the overall body to be a entire single geometry to be applied with the same kind of composite material. Just the variable thickness will be applied in the thickness direction, so we don't have to worry about the separations in the model or discretizations in the model. So once the mesh is created over here, I'll minimize the screen. I'll just click on the model so that the mesh should be updated directly to the setup over here. So I'll click on update over here in the model. So once the model is been updated now, I have to open the Ansys ACP setup over here. So I'll click on the setup, right click on it and click on edit. So usually it doesn't take much amount of time to load the ACP. So we'll just wait for some more moments over here. Okay. So now this is the particular graphic user interface for your Ansys ACP pre, which is the part of Ansys composite pre-post. So over here, as you can see, our model has been opened over here. As you can see, if I would zoom over there, there are no mesh elements. Those have been imported. But if I would click on the mesh over here, this is also the similar kind of interface that we have in Ansys mechanical, where you can see the particular mesh, where you can select the particular like entities which are present on your body. You can see the fiber orientations over here in the normal direction, in the orientations, even the particular like if there are any kind of fiber orientation in the particular like angular directions and all. So you can see all those things in the particular manner once we will define the particular layups, the plies and all for your particular geometry over here. So these all tools can be utilized once you define the plies and once you apply those for your particular geometry over here. So first of all, on the left hand side, as you can see over here, this is the process that you all usually need to follow whenever you want to perform create a composite material over here, or you want to create a ply, or either you want to create a solid model of the ply that you are usually creating with respect to the composite. So all that process can be done using the tools which are mentioned over here. This is a particular console system which is available over here at the bottom, which will showcase what kind of process that you are following over here. And this particular Python code, you can directly share it with anyone if you want to share the particular details of your composite material and how you have designed the overall process can be shared with respect to this Python coding which is available over here. Then the history view will show like what kind of things that you have done with respect to your particular generation of the composite over here. Then this is the particular graphic user interface where you can see how the plies are applied for your particular geometry, what are the fiber orientations, what are their thicknesses, how the plies are oriented properly, whether the thicknesses have been defined in a proper way or not. As of now, you can see this particular body has a thickness of 1 mm. This 1 mm thickness has been imported from your particular Ansys mechanical window over here, but this was for 1 mm, but over here it has been imported in the form of units in the form of meters. But we need to initially change the unit system whenever you are proceeding with Ansys mechanical, Ansys ACP, because the unit system should be a like a constant unit system should be followed whenever you are processing with composite designing and all. So it should be unit consistent system. So I'll just make use of the megapascal, that is in terms of over here. So I'll use this particular system for doing the creating the simulation, creating the composite materials. First of all, I have the material data over here. In the material, I can create the fabrics, I can stack up them, and then later on, once those are stacked up, I can define the particular orientations for these stack ups that I have created with respect to the fibers and all other things. And then later on, I can define the particular ply models through them. So first of all, I'll click on the materials to see what kind of materials that I have imported from the engineering data. One is the structural steel, the core material that we did created, and the epoxy material that I did selected from the history. Sorry, the library. So first of all, we need to begin with creating the fibers from this particular material. So I'll just click on the fabrics over here, right click on it to create a fabric material. So first of all, I need to choose through which particular material I want to create a fiber over here. So I'll just select the particular epoxy material that I did used. I'll use that particular material, define a thickness. See, these particular values that I'm mentioning over here are just random values. You can define your own values whenever you are proceeding with your particular projects. So as of now, I'll just define some random values over here. I'll define the thickness to be 15, to be 0.2 and then apply it over here. Once it is applied, a fabric will be created with respect to this particular epoxy material. Click on OK. Now this particular material, sorry, I'll just edit the name as well so that it will be easier for recognizing. So I'll name it as woven. Apply and OK. Now the second fiber that I want to create is with respect to the particular core material. See, whenever you are importing any kind of material, that particular material can't be directly used for generating the composites or the laminates. So you need to create the fibers through the particular material that you have imported over here. So I'll just create the fabric over here once again for the another material that is the core material. Define its thickness to be 15. Okay, so let it be 15 itself. So I'll make it as 15 and apply it over here and okay. Once this is done, even I need to change the name for this particular material as well. So I'll name it as fabric core. So once this is done, apply it over here and click on OK. So once you create the fabrics from the materials that you have imported, the particular use of the material has been done. Now, whatever the use will be done, that will be of the fabrics. So the process that we usually follow, that is the sequence that we usually follow for the composite generation will be the same. That means whatever material that you have imported over here, those materials will be used for the fabric creation. And through the fabric creation, you can define the stack ups over here. So the stack ups that we were we're going to use will be of this particular orientation for just the single material, that is carbon material that we have imported. So I'll just click on the stackups over here, create stackup. So first stackup I need to define. So I'll name it to be as -45. With respect to its orientation itself, I'll mention the particular stackup name as well. And so once this is defined, the next thing that I need to do over here is, so it is not a particular symmetry that I want to use for this particular stackup. So this will be a particular top to down approach, or either you can choose it from bottom to up as well. So this will be a top to bottom. So I need to define the top to bottom. That is, the first fiber orientation should be at -45 degree. The second should be at 0, and the third should be at 45. So first fiber will be my particular fabric oven itself. So this particular stackup is created for a just single material, single fiber. So I'll just use the single fiber itself for 3 times over here. That is fabric oven for 3 times, and define the particular angles to be -45 degrees. The second will be 0 degree, and the third will be 45 degrees. Once this is done, I'll just click on apply. Once it is applied, you can see the analysis, the particular things can be seen over here. Then I'll click on general, apply, and OK. Once you create a particular stackup for this particular material, you can now proceed with your another material, that is your fabric core. So first of all, once this is created, I'll just go for the another material. So before that, I can just showcase one more thing over here. So we can see this particular strength as well for the mud stackup that you have created. So, okay. So you can see with respect to the polar properties of your particular stackup orientation, how the strength of your particular ply has been increased, or whatever the stackup that you have created, how the particular strength of your particular fabric has been increased. And you will have a particular introduction to the production ply and to the analysis ply. So production ply will be the particular, all the three plies to be particularly like combined in a single ply itself, and that will have a single thickness for all the three plies that you have like designed or you have particularly modeled. But analysis ply will be a particular separate plies, which we will use for the composite simulation in the further analysis as well. And in the polar properties, you can see how the particular strength parameters are getting affected or either getting increased over there. So once this is done, I'll just click on apply and click on close over here. So you can see that even there are the element set. Element set are the particular name selections that you do usually create. But over here, we didn't create any name selection from your particular geometry. As you can see, the overall geometry was just a single kind of body that we have defined over here. And for overall body, there is just a single kind of mesh that has been generated. If there would be some name selections defining this should be some different body, this should be some different face or some different body, then the elements those are present on these particular surfaces would be also shown in this particular element sets over here. And they can be used for defining different kind of composite in those particular regions. So over here, I will use the overall material which has elements which are available on the overall geometry itself for ply orientation and ply modeling. Then I'll do update the particular element sets over here. Then the next thing that I need to create is the rosettes. See, rosettes will let you know how the fiber orientation should be done and all other directions of your particular fibers with respect to your particular model. So all those things can be set with respect to the rosettes which are available over here. So first of all, I need to create a rosette over here as well. So the rosette that I want to create for this particular model should be parallel to this surface. See, this rosette will decide how my ply should be how my ply should be, or how my fibers should be placed on this particular model with respect to the surface. So they should be parallel to this surface itself. The origin should be at the center itself. but it does varies with respect to different kind of models as well. Over here, the direction of your ply, first direction should be your X direction and the another should be your Y direction itself. So these are some correct kind of inputs. Those have been defined for your particular model. So I don't have to change anything over here. But when it comes to complex kind of structure, at that time, you can even choose this particular direction with respect to the elements those are present over here. You can change the directions with respect to the elements which are placed on this particular model, because there might be some kind of orientation that might get changed with respect to other geometries. So you can even change the rosette types, like how the fiber should be oriented with respect to your particular model, that can be defined with respect to these two directions which are mentioned over here. And once this is correct, just click on apply and click on OK over here. So once these things are done, what you need to do the next is you need to create the oriented selection sets. So whatever rosette that you have created, and with respect to the elements, you need to create a particular oriented selection set over here that can be directly applied to your particular stackups that you have created to create a plan. So this particular oriented selection set I will create for a new for this particular geometry over here. First of all, I need to select the particular element on which the orient OSS should be created. So this particular OSS should be created for all the elements which are present on the body. So I'll just click on all elements which are present over here. Then the next thing that I need to do over here is I need to define the particular direction in which the thickness or the particular normal direction of this particular body is. So over here, the orientation means that is the particular thickness direction that you are trying to define for your particular uh, fiber or particular ply that you want to generate. So it will be particularly normal direction. So orientation will always define the normal direction to the particular fibers or to the particular model on which you are trying to apply the fibers. So over here, the normal direction will always be your Z direction. So I'll make it as 1 over here. Then once this is done, the rosette that you have created, you need to apply it over here so that the particular fiber orientations will also get shared with the OSS over here. So I'll just select the rosette as well over here and click on apply. And once again, click on OK over here. Now the particular orientations and all other things are shared over here. You can see the orientation, that is the normal direction to your particular surface or particular element generated on the body will be your particular orientation direction. Then your particular rosettes, whatever the like the normal directions for your particular fibers will be showcased over here. Then the fiber directions will be showcased to you with respect to this particular thing. These are just some kind of rosettes that you have created. The orientation that you have applied for your particular model is being showcased over here. This is not with respect to the fibers orientation, because you didn't apply the stackup that you have created, which is present over here, or the fibers that you have created over here. You didn't apply them to the particular geometry as of now. But once you apply them over here, the particular fiber orientation and all other things will be showcased to you with respect to that manner itself. Then you can see other particular parameters as well when we'll apply the particular other things to your geometry over here. So once the oriented selection set is created, the next thing that we need to do over here is, yeah, just a second. Yeah. So once the oriented selection set is created, I need to go for the modeling groups. Modeling group is the thing where we can generate the plies for your particular model now. So how the particular plies should be applied on your model. So what should be the initial ply? Then there should be a core model for your particular geometry. And then there should be another ply for the woven material, so that the core will be get stacked within those particular woven materials, and the particular strength of the body can be increased with respect to the core material. So over here, I need to design this particular modeling group or plies for your particular model in the similar way. I can right click on this modeling group and create a new modeling group over here. So this particular modeling group can be named as particularly, you can keep it as it is as well, or you can name it as ply grouping over here. So as of now, I'll just keep it as it is, naming it as modeling group itself, and right click on it once again and click on create apply. Now with respect to whatever the stackups that you have created, with respect to the fibers that you have created, and with respect to the element sets, row sets, and the particular oriented selection set. See, the oriented selection set is a combination of your row set and elements. So basically you don't have to use this both the things for defining the ply orientation over here. Instead, you can just use the oriented selection sets to create the ply. Even the thickness direction can be also defined with respect to the oriented selection sets itself. So this is a combination of row set and all element sets over here. So I'll just click on create ply. First of all, I'll just name this particular modeling ply to be ply 1. Ply 1, and then the oriented selection set, I need to define it over here. So I'll just select the oriented selection set that I did created for the model. Then what kind of materials that I want to use over here. So first material for the composite that I am trying to define for this particular model will be your stack up model, that is with the orientation of -45, 0 and 45. Even I can use the fabrics also which are present over here in the particular model. So I will first of all use the stack up over here. So the stack ups are defined. So number of layers will be just one number of layer, and global ply number will be your first ply laminar. So basically whatever the stack up that I am using, it is my first ply that I am defining for this particular geometry, and later on whatever the number of plies that I will be defining with respect to this particular stack up itself, they will be defined for this model. So once this is done, I can go to the thickness as well. So over here, the thickness of this particular ply, the stack up that I have created, will be will all automatically get calculated with respect to the particular fabric thicknesses itself. But for the core and all other things, or with respect to the varying dimensions of varying thickness of the particular model, it can be even modified with respect to the thickness which is available over here. As of now, I don't want to change the stack up thickness, which has already been defined over there. So I'll use the same kind of thing. I'll apply it over here and okay. So once that is done, you can now see the particular orientation of the fibers and all other things. You can see the orientation of the fibers, that this is your particular normal direction to the plywise. Then you have the orientation with respect to the plywise direction. Then the fiber direction you can see with respect to the rosettes that you have created. Then this is your particular ply direction, fiber direction, sorry. Then there might be even the transverse direction for your particular things. So all other things can be applied in similar way. So as of now, we have just applied a single ply over here, which has all the three ply laminates that we did created, all the three fibers that we did created in this particular fabric oven, sorry, stack up. So basically all these things have been applied to your particular geometry as the initial ply. Then the next thing that we need to apply about this particular ply will be your core material. But if you see the geometry which is available with us, this particular geometry has an varying thickness with respect to its particular lengthwise direction. So this particular varying thickness, how we can define it over here in the Ansys ACP is, you can go to the workbench screen. Once your particular ACP has been done, like once you have defined the particular fiber selections, then the stack up creation, then the particular rosettes and orientations have been created for your model. And then what you can do over here is, you can just create a section cut so that you can see how the particular plies have been applied with respect to the particular thickness of this body. And then later on we'll decide how the particular varying thickness can be applied. So what I'll do over here is, I'll just create a section cut. This section cut should be created for the interactive plane. So the normal, I'll create it for the particular Z direction itself. Okay. So the normal, I want it to be y. Okay, so I'm not able to properly zoom it over there. Okay. So previously it was with respect to the modeling plywise. Now it is with respect to the particular analysis plywise. So as you can see, there are three number of plies those have been showcased over there. So I'm not able to move it over here, but as you can see, there are three number of plies that have been showcased over here. So first, second, and third, they have all these three have the particular different kind of orientations. Okay. Okay, let it be. So once this particular section plane that I have created over here, it was just to showcase you how the particular like stack up has been applied for your particular geometry. You can see there are three number of lines. Those are just showcasing over here with respect to your particular fabrics which are present in the stack up. So all these three fabrics have been applied in this particular first ply. Then the second ply that we have over here is might have some variable kind of thickness, because as you can see to this particular image, the particular ply thickness does also varies with respect to it. And you can see the particular thickness over here, how it is getting like discretized, or you can say how it is getting distributed over the span length. So basically we need to create the same kind of variation in the model. For creating the variation, what I can do over here is I can just go to the particular workbench screen over here, whatever the geometry that represents the 3D model of your particular kiteboard. So I'll just import that particular geometry over here. So I'll just select the geometry, import the file which defines the particular thickness uh, in the particular normal direction to the surface of the kiteboard. So this particular model, I'll import it over here. Once it is imported, I'll just drag this model and import it into the setup of the ACP. Once this is imported over here, I'll just right click on the setup and update it. Okay. So once the setup is updated over here, I'll just go to the ACP, and over here you can see there is a particular CAD geometry that has been imported, which is your kiteboard course step file. This particular kiteboard step file, you need to import it in the particular virtual geometry as well, so that this particular virtual geometry, because directly the CAD geometry can't be used for the particular like defining the thicknesses and all. The virtual geometry can be used for defining the thicknesses. How the thickness can be defined with respect to the geometry is how we did created the ply which was present over here. We'll create the same kind of ply, but we can define the thickness of that particular ply. Instead of defining it with nominal thickness, we can define it from the geometry. So this thing can be done over there. If you choose it from the table, you need to import the particular Excel data with respect to the orientations in the XYZ directions. And over here, there are some advanced kind of settings those you can do with respect to the thickness of the plies. So those kind of things will cover in the upcoming webinars. But as of now, to keep it as a basic kind of simulation composite model, we'll go with the particular model which is already been available with us. So if sometimes the model is not available with you, then how you can define those things with respect to the tools which are present over here. We can discuss about those in the upcoming sessions. Over here, what I'll do is I'll just right click on this kiteboard geometry, go to the properties over here. You can see the properties for your particular kiteboard model, and you can see this variable thickness of the kiteboard model over here. This particular thickness can be applied because this is a particular variation thickness with respect to the length of the kiteboard. So I'll just go to the virtual geometry over here, right click on the virtual geometry to create a new virtual geometry. And this particular virtual geometry is supposed to be created with respect to the kiteboard. So I'll just select this kiteboard model over here and I can create a virtual geometry through it. So this particular virtual geometry itself can be used for the particular simulation. So sorry, for the particular ply thickness to be defined. So over here, once this virtual geometry has been created, what I can do is I can just go to the particular ply modeling once again over here. In this modeling group, I can define, create a new ply over here, or either in this ply one itself, I can create a new ply. Create apply after or either before it is asking. So basically, if you are creating a ply within the ply that you have created, then you can create the ply before the ply that you have applied on the model or after the ply that you have applied. So we want the particular ply to be applied above the ply that we did already created, so that the particular core material ply will be applied on the particular center, or with respect to the thickness direction, it will be present at the middle of the lower ply and the upper ply, which is made up of the woven material. So over here, if I would click on the ply, I'll click create a ply after the ply that I have created of the woven material. So the orientation sets will always remain the same for this particular model because the thickness direction is the same for all the three materials. So I'll just select it, apply the material to be fabric core. Now the thickness and all other things will be taken from the particular fabric material itself. But if I want to apply the variable thickness, I can go to the thickness over here, choose the type of the thickness from nominal to from geometry. This particular geometry should be your virtual geometry that you have imported. It will automatically get applied over here and click on apply. Once you click on apply over there, click on OK over here. Now, if you would check the particular thickness over here. Okay, so it hasn't been updated yet. So let me just check it once again. Fabric core ply angle. It should be my global ply number 4 because there were already 3 plies in the first ply itself. So I'll apply it and make it as okay. Once this is done, what I'll do is I'll apply the third ply as well. So in the modeling group, because I don't want to apply directly over here on the particular like core model that I have imported on this particular geometry. I can create the another ply that will start from the particular initial till the another end of the particular body. So I'll click on create ply over here. Again, the oriented set will be your particular same oriented selection sets. The material will be again your stack up layers over here. And this will be a ply number 5 and apply and close it. Now click on the section cut once again over here and update it. Once you would update it, you can see the particular thickness of the ply with respect to your thicknesses of the sorry, whatever the thickness that you have defined to the ply, you can see the variation of the particular thickness with respect to that ply model itself. You can see there is particularly three number of plies which are present on the bottom layer. There is a ply which is present at the middle layer over here, and there are three more layers which have been created at the top over here. Those are defined with respect to the strips over here, that is the line models. So every ply is being defined with respect to a line model. So the thickness of the particular line model does depends on just a second. I hope so. My screen is visible, right?
Yeah, it's visible.
Yeah, okay. Okay. Once these particular thicknesses and all other things are applied to your particular geometry, what you can do is your overall like pre-processing part for your composite generation has been applied for your particular model now. You can use this particular model and take it for the structural simulation further. So once all these things are done for your particular composite creation, see, as this was just the initial process that we did followed over here. What you need to do from the initial is you need to create the materials for your particular composite material creation, select the materials for composite material creation. Through those materials, create the fibers with respect to the thickness. Those are supposed to be defined for the material for the fibers. Then later on, if there are some kind of fiber orientation and the same kind of fibers are being repeated, or either if there are multiple number of fibers, those are being combined and just a single stack up is getting created over there. You can create the stack ups over here so that it won't be much difficult for you to define the fibers again and again in the particular ply orientations over here. So basically, to avoid like more number of fibers to be selected to create a ply, you have a stack up that will help you with creating a particular like composition of various number of fabrics in it with different kind of orientations. Once those are created, then later on, whatever the element sets that you have created, the fibers or the particular like stack ups will be applied with respect to the element sets that you have on your particular model. You can select the overall model as well, and even whatever the name selections that you will create with respect to those as well, you can define the particular stack ups and fiber orientations. Then later on, once those are done, you can create the rosettes. The rosettes are basically the particular tool which will define the not the normal direction, the fiber direction and the particular transverse direction of your fibers. And then later on, the particular oriented selection set will be a particular combination where the fiber direction and the transverse direction and the elements on which the fibers should be applied. All those things will be combined together, and the particular normal direction of the oriented selection set will decide in which direction the particular thickness of the thickness of the ply should be generated. Then once these things are done, you will create a ply using all those things, and you will select the particular sequence of how the ply should be applied on your model. So first you will have a particular ply that you have created with respect to the stack up layers. Then the second ply is your particular fabric core with respect to the varying thickness that you have defined. And the third one is your particular another stack up ply that you have applied, so that the core will get particularly covered within it, and there will be more strength provided due to the core to the overall body material. So once all these things are applied, the section cut is just to see how the particular fiber orientations has been done and the thickness with respect to the particular surface of the model. So all these things can be done in the pre-processing part. Once all these things are done, minimize your screen, update the setup which is present over here, and now drag this particular static structural analysis system and drop it over here so that you can perform a structural simulation on with respect to whatever the material or whatever the composite that you have created. So I'll just drag this setup over here and drop it on the model of this static structural. And whatever the model that you have created was with respect to the shell elements, not with the overall solid body. See, solid body composite analysis, composite pre-processing is something different, as whatever the process that we have followed as of now, it is with respect to the shell, that is with respect to the surface model. So we have to transfer the shell composite data over here. So I'll just select this particular shell composite data and open this Ansys mechanical over here. Okay. So once this is done, now you guys can see over here the particular geometry and the thicknesses and all other things that we did define for the geometry has been locked over here. Now the material assignment is your composite material that you did created in the ACP and that you have applied to the geometry, and even the particular thickness of the shell is defined by the composite layers itself, the plies that you have created, and all the plies that you did created over there has been imported over here now. As you can see, there are three number of plies over here in the first stackup. There is a single layer of ply in the second one, and there are three more number of layers in the third one. So all these things are available over here. Even the mesh that you have generated is also available over here. So as you can see, the mesh that we have over here is not showing the 3D like the thickness direction of your particular geometry, as the mesh that we have created is the shell mesh. So we need to turn on the particular thick shell and beams so that you can see the particular thickness in the whatever the particular third direction is there. So as you can see the thickness of your particular geometry in the varying way. So all these particular things has been done through the particular ACP pre-processing part itself. Once this is done, now later on what we have to do over here with respect to this structural analysis is I'll just apply the boundary conditions and loading conditions so that we can analyze the composite that we have created over here. So I'll just right click on the static structural, right click and insert a particular force on this overall faces of the body. So these were the conditions that I did already got from this particular simulation file itself. So I'll apply the particular force on all these 9 faces of the body, make the particular force direction to be defined with respect to the components so that it will be easier for me to define it. So the force that I'm going to apply on this particular geometry, it was supposed to be considering that the kite board should get like the particular weight that this kite board is getting used with is something nearly around a particular person that is being hanged with it is of a weight that is something around 115 kgs. So in terms of Newton that I can apply it is something 1029 Newtons. So that I'll apply on this particular surfaces of the geometry. Now this is the particular loading condition that was provided for this particular model. Now what we can do over here is we need to constrain some of the end of the body. So if they have considered this particular kite board that has some kind of boundary conditions on one of this particular part where the displacement in the model has been controlled, so that this particular force that we are applying won't create any kind of over constraint or under constraint issues over here. So what I'll do over here is I'll just apply the boundary condition. The boundary condition that I need to apply is the remote displacement over here so that I can constrain the motion of this particular kite board model. So this particular thing is needed to be applied with respect to the name selection. So first of all, I'll create the name selection for this particular body, which is a rear binder model. We call this particular thing as rear binder. So this particular rear binder, I need to create a particular remote point first of all to directly apply it with respect to the remote displacement over here. So first of all, I'll create a remote point over here. Then apply it with respect to the name selection to the rear binder. And this particular behavior of the particular remote point should be deformable. So that's why I did created a remote point over here. And now this particular remote point, I'll apply it over here for the remote displacement. The remote point and the particular thing that I did selected over here. So all the 6 directions, I'll respect to the constant term. So all the 6 directions I have constrained it over here for this particular model. Once this is done, I'll just go to the solution and insert the total deformation over here. Insert the particular stress that I want to analyze for this particular model. See, this particular stress results can be generated with respect to the ply wise as well. So whatever plies that you have created, you can analyze the particular stress generated for each of the plies which are present over here. So whatever the plies that you have imported, you can select any of the ply and that particular thing will be applied over here in this ply selections. So I'll just select it and apply it over here. So whatever ply that you want to analyze for whatever ply or whatever stack up or whatever the kind of fiber that you have applied for this particular model, if you want to see the particular stress generated on those kind of things, you can just go with this particular process over here. I'll just go to the solution and even insert the composite failure tool as well. So once I'll go with the composite failure tool, I need to select something that I want to analyze the failure in the composite with respect to. So I'll go with maximum stress because we have defined the particular stress limits over there. And over here, I want to analyze the core failure, whether the core in the particular model gets failed and in which particular region there are more chances of the particular core material to get failed. So I'll just turn on all these things, all these configuration models over here and do the particular solution solved. Okay. So once the simulation is got solved, if I would go to the total deformation. So as you can see for this overall model which is present over here, due to the particular conditions that we have applied, that there are more particular chances of being applied the force on the overall model, but the rear binder is applied with some kind of remote displacement, which is totally constraining the backward part of the particular kiteboard model over here. And due to which there are more chances of deformation to be generated at the another end of the model. So as you can see the particular deformations over here. And if I would increase the particular auto scale to some highly extensive scale, you can see there are how the particular chances of your model are there to get deformed in which particular direction. So not just these things, but even the equivalent stress, as you can see over here, the equivalent stress that I have used for the particular ply model is showing that there are more chances in this particular region of the model to get failed. But if I want to analyze it for the particular core material, so I can go over here. Instead of this particular material, I can go and select the core material and apply it over there and again evaluate all the results. So over here, you can see there are more chances for the particular material to get filled, the core material to get filled over this particular region, which is present over here. So if I would go to the composite failure tool as well, in this particular region as well, it is showing there are more chances to get failed in this particular region due to the remote displacement that we have applied on the rear binder over here. So this is the particular region that most of the stress is getting generated and the failure occurrence chances are also high in this particular region itself. This is how the post-processing part is done in Ansys Mechanical. You can even turn on the worksheet over here and you can do the particular simulation for your model, for your particular model that you have created the composite of. So basically, once this particular composite is analyzed in the Ansys Mechanical, you can go for the composite analysis in Ansys ACP as well. The process over there will be a little bit like kind of changed kind of thing, a little bit varied kind of thing. So over here, what I need to do for doing the post processing using the Ansys ACP tool is I'll just select the ACP post over here and drag and drop it on the particular model of ACP pre. Once I'll drag and drop it on the ACP pre model, all the things those are present in the ACP will be shared automatically over here. And the solution that I have got from the static structural, not the result. The solution that I have got from the static structural, I'll drop it over here in the ACP post. Once all those things are done, I'll just update the project over here before directly jumping on the result section in the ACP post. So over here, I'll just now open this particular result section. Okay. So once this particular section has been opened, that is the ACP post processing section. Now I can go to the particular solution over here. In this particular solution, if I would double click on it, you can see it has taken all the data that was present in the Ansys mechanical post processing, Ansys mechanical solution. So I'll just update it over here. Now, what kind of solutions those are available in Ansys ACP post to analyze over here for this particular model can be seen by right clicking on the solution. You can create a deformation plot, stress strain plot, failure plot, temperature and all other plot if those are your particular things to be determined for your particular model. So over here, I'll just click on the particular deformation plot at the initial. This deformation plot should not be scoped for the overall model or should be scoped for the overall model, but the overall model is not available over here. We have sets which are present over here. So we'll go with the elements itself, which we have created. Those are all the shell elements with respect to the thickness of the composite that we have provided. So we don't have to worry about the overall model. So if I would select all elements over here and then apply and okay. So as you can see, the similar kind of result that we have got from the ANSYS mechanical are being showcased over here. The particular deformation, as you can see, the higher amount of deformation in ANSYS mechanical is also being showcased over here in the ANSYS ACP as well. In the similar way, you can analyze the stress as well. The stress can be analyzed instead of overall model, you can define the particular data scope and it can be ply wise. So if I want to particularly define the data scope over here, I don't have to select all elements. I can go even for the models that I have created. That is the ply that I have created. So for each of the ply that I want to analyze for, I can just click on it. Okay. So as you can see, the stress generated on the particular model is being showcased over here with respect to the first ply, which is at the bottom of this particular screen over here. Now, if I would try to go for the particular core material, which is available over here, so I can just select it. You can see the maximum amount of stress that is being generated on the core material is also being showcased over here. So you can analyze each and everything in a proper way. You can see which particular element is getting more highly stressed and more high chances of failure are there on which particular elements of the body. So all these things can be analyzed over here and you can try to improve your particular model in such kind of regions over here. Once this is done, you can even go for the particular failures as well. But failure needs to define the particular criteria in the definitions at the initial. You can define the failure criteria over here through whatever the kind of things that you have defined in the engineering data for the materials those are available. So we have defined the strain stress limits over there. So we'll configure it with respect to it itself. So we will apply it and then okay. So once this failure criteria is created, you can even apply the failure plot over here and the failure plot with respect to the failure criteria that you have created. And the same you can go with the ply wise failure criteria for your particular model can be done over here. So instead of this, all elements, and this can be done for each of the particular. So you can see the particular failure criteria for your particular model is being showcased to be nearly equal to 1. So this is how the particular simulation is done. The overall simulation does includes lot number of components over here in the workbench parameters. But if you don't want to go with such higher amount of complexity with the model, then you can just do the post-processing part in Ansys mechanical itself, which is present over here, which might be a little bit more easier and more comfortable with reducing the complexity in the overall structure of the analysis. So this was all which was supposed to be showcased in this particular webinar, where we did covered how the particular materials are selected, how the fibers are generated, then how the stack ups are created, how orientations, rosettes are created with respect to the fibers and all. So all these things we did analyzed over here. You can see the result that we were expecting from this particular model are showcased over here. And how does the actual model does undergo such kind of failures in the particular model in that region itself. You can see the results those have been showcased with respect to the actual model. So this is how the particular simulations can be done. And in this particular region, you can either increase some more amount of strength to the material by changing the material properties and all, or either you can provide some more amount of thickness in this in that particular direction, in that particular region. So this was all about this particular session. So the upcoming sessions, which will be in the kind of series itself, so they will cover more such kind of applications with more advancement in the particular session. So whatever the tools that we did applied over here, those were some basic kind of composite tools. So in the next session or in the next series of webinar, we'll try to cover more advanced tools over there. So if anyone has any kind of doubt, please let me know in the chat box itself. So previously, Pranjal, it was not available in Ansys Mechanical to do the post-processing part for the Ansys ACP. We were not having more particular parameters or particular tools through which we can analyze the results for your composite material in Ansys Mechanical. But now they have integrated the Ansys Mechanical with such kind of tools through which we can analyze the composite data more feasibly. And in the latest version, there are even more number of tools through which we can analyze them. So it is more efficient and more easier to do the particular post-processing part instead of ACP doing it in Ansys Mechanical itself.